Hello, everyone. This is Angie with Angie's Beyond the Lecture, and this would be the sixth installment, I believe, on my chemistry final exam review series that I'm putting out on YouTube. And this particular section, we are going over scientific notation and also significant figures. They sort of go hand in hand. And before we hop in, just make sure you check out the entire series if you would like. It's a free course out on YouTube, and it covers the basics, including types of matter, measurements, scientific notation, significant figures here, the anatomy of an atom and isotopes, and so on. So it's a really good review of the first, I would say, quarter to a third of chemistry studies, whether you're in high school or taking college chemistry. So there's that. Back to the topics at hand, we have scientific notation. This is a very, very common notation used in chemistry. So a lot of times you're dealing with either really, really tiny numbers or really, really large numbers, depending on the topic or subject. And you just need to be able to negotiate taking standard numbers, or what we call ordinary numbers, to scientific notation and vice versa. So you have to either go from a testing standpoint, you need to go from either ordinary or standard number out to scientific notation or vice versa. Take something in scientific notation and go back to your ordinary number setup. Now, the examples I have here are taking regular standard numbers over to your scientific notation. But before we do that, we just need to go over what that notation looks like and sort of the rules, which are pretty basic here. We have a number, A, has to be greater than 1, but less than 10. So it's between 1 and 10. We call that the coefficient. N is a power, and it has to be an integer. So for an example, I could just say, I'm going to write this off to the side, 5 times 10 to the third power. So that means I'm taking 5 and, in essence, adding 3 zeros behind it. And again, hopefully most students who are reviewing this have an idea of how scientific notation works. It's simply a review. I'm sure you've used it throughout your lab work and also maybe on your chemistry homework assignments and probably online with like Pearson and WebAssign and so on. But I'm going to show you how to convert, how to just take a regular number and convert it to scientific notation and vice versa. And I'll use these two examples here. Take the first example here. We have 3,500. We want to put it into scientific notation. Now, before I move on, just remember we have some examples to work on, and we'll do both types, scientific notation to regular numbers, and then regular numbers out to scientific notation. So no worries, plenty of practice. Now, if I take 3,500 and I want to put it into scientific notation, remember my implied decimal point is right here. And in order to put it into scientific notation, I'm moving it back 1, 2, 3 spots, or 3 decimal points or decimal places to get my 3.5. So when I'm making a larger number into a smaller number, I need to make sure that exponent is positive. And it should make sense. We're taking 3.5 and making it a larger number. So in the end, we move 3 decimal places to the left. You make that a positive 3 exponent, and you're good to go. And always remember, when you're practicing these, maybe you're a little bit rusty, or it's been a while, or you're just learning this concept, you can always simply apply the rules of scientific notation that say when your exponents are positive, you move the decimal to the right. When it's negative, you move to the left. And that should be intuitive. Okay, so positive implies you move to the right for your exponents. And then negative implies that you move to the left. Okay, so if I'd accidentally put like 3.5 to the -3 power, like I just changed that +3 to a -3, I'd be moving my decimal point to the left, and I would have 0.0035, and that's clearly not 3,500, right? So a little bit of practice, you'll get it. Now in the second example, take 8.2 times 10 to the -4. I'll just show, I'll demonstrate how you get 8.2 times 10 to the -4 over to that particular answer. So you take 8.2. My pen just wants to be a little stubborn today. There we go. 8.2 times 10 to the -4. I'm just preparing myself with some zeros. So we're going to go ahead and move this over 1, 2, 3, 4. Okay. So that would be, and yes, we're definitely going to want to clean that up. And in the end, we'll have 0.00082, okay, which is the answer I have right there. So again, scientific notation is just a way of taking really large numbers or really small numbers and putting them into more manageable number, okay? And your TI can definitely handle those numbers, whether you use the caret symbol or use your exponent function on the TI. I have a TI 84, works great with those. I think that's it for this section. And I did cover, if you give me just a moment, I'll back out here. And we'll see the common, scientific notation is commonly seen in the following quantities in chemistry. We have atomic masses, wavelengths, and concentration. So wavelengths are typically nanometers. So you might have something like, 750 nanometers, but technically you need to use the meters. So you have to apply 10 times the -9, which we're actually going to look at here shortly. We'll look at taking the SI prefixes, the Greek, I think it's Greek or Latin prefixes, and converting up and down the scale. Now, significant figures, oh, and I'm sorry, one more thing, concentration. So for instance, like acids and bases, they have really, really tiny amounts of concentration. So like an acid could have an H plus concentration of, say, right, it's very, very small. And, or even like 3 times 10 to the -8. These are just random examples here. And it's simply easier to just put that in scientific notation versus writing out all those zeros. Okay, so it is largely to save our hands. All right, now significant figures. Yes. In the beginning, I think this can be a tough section for students, and it's often visited or sort of hammered home in lab. Okay, so your lab teacher is definitely going to be looking at your measurements, your significant figures when you're doing calculations. Are you applying the right rules when you add, subtract, multiply, and divide, and so on? So from a lecture standpoint, you'll probably only be asked, okay, if I give you a number, can you tell me how many significant figures are there in this particular number? Or here's maybe a standard calculation, report that final answer in the correct number of significant figures. So we'll go over that real quick, and then we'll be on to the next section. Now, significant figures, again, they indicate how precise a measured value is, and they include all known digits plus an estimated digit. And I touched on that briefly when I talked about the electronic scale, right? And it could take it out to perhaps, 4. Say like I put something on the scale and I got 4.2500 grams. I was really good at measuring and getting that exact value, but there's a certain uncertainty on that last digit. Now, the basic rule for counting significant figures, because that's what you'll probably do or need to do in lecture when it comes to quizzes and exams, is that you'll just need to tally them up and give you a grand total. So All non-zero digits, those are considered significant. Zeros between non-zero digits are significant. So if I have like 203, that zero in the middle is considered significant. It's a placeholder. I need to count it. Leading zeros, not significant. So if I have like 0007, none of those are considered significant, just that one right there. Trailing zeros are significant only if there's a decimal point present. So perhaps in this scenario, yes, I would count 3, 5, and then that trailing zero. And I did run through a few examples here for clarity. When we have, now we have 0.0025, we'll count those two as significant. Okay, remember, leading zeros don't count. Now 40.50, all four are considered significant. We do have a sandwich zero right here. We do have the 4 and the 5, of course, they count. And then we have a trailing zero right here that counts. So both zeros in this figure, or this number, actually count as a total for significant figures. So we do have 4 total there. And then last but not least, I'll erase for clarity here. We have 5,300 or 5,300. We only count those two, the 5 and the 3. So unless I have a decimal place, and a lot of times you'll see on homework or maybe online homework or written homework, you'll have a decimal, an explicit decimal that says, yeah, I want you to count those 2 zeros. So this would actually be 4 sig figs. But here, as it's given over here on the left, 5,300 only has 2 significant figures. So I wanted to clarify that important distinction. And then last but not least, so in addition to being given a number indicating how many significant figures you see in that number, you also have to do some calculations. So they'd like to, chemistry likes to spice things up a bit. And the key thing you need to understand is that when you add and subtract, you are going to limit your answer by the number of decimal places. And in multiplication and division, I kind of like this scenario a bit more because you simply tally up the sig figs and say like you're doing multiplication. You just answer in the number with the lowest number of significant figures. It kind of takes the guesswork out of that. And largely your calculations will be based on multiplication and division. And to be clear, I realize some students say they really take sig figs seriously, and I wouldn't, as you progress through the semester, definitely, especially when you're doing multiple choice questions, likely your teacher's going to give it in the correct number of sig figs. You just have to get to the right answer, okay? So do keep that in mind. And again, significant figures are largely, I would say, monitored on the chemistry lab side, but don't expect to not be tested in lecture. Definitely know how to identify the number of sig figs in a particular number given and how to do calculations. And I'll run you through a couple here. For instance, if I take 63.5 and maybe 22.23, okay. So I'm going to add those two together, and this is something I can do manually, I think here. Yeah, we'll have 85.73. Now I need to cut off, and then the easy thing you can really do is just simply cut it off, cut off that hundredths place. So I can only report in my final answer 85.7. That 3 at the hundredths place just tells me to keep it at 7. Now remember, when you have 5 and above, you give it a shove. Okay, so if that were 85.75, I would round it up to 85.8. But this answer is just going to be given a final answer of 85.7 units, whatever they happen to be. We'll go ahead and do some more work at the bottom. Let's see here. So I'm going to have like maybe 25.3 times 7.9. Okay, and I'm not going to do that in my head. I'm going to grab my TI and run it out here. Okay, Ooh, okay, interesting. So I have 199.87. I did not do that on purpose. That's a little wonky. So we have 3 sig figs here. We have 2 here, and I should be reporting, right? I should be reporting in that particular um, format of 2 sig figs. And gosh, so that would be right there, right? I would say 199 would actually bump it up to 200. 200. And right, so what I'm doing is I'm saying, okay, 9 is going to bump that up to 20. And this, of course, is in the hundreds place. Now to report it, technically that's only 1, right? Technically that's only 1. So the appropriate thing to do would be to say, I'll put this in scientific notation and report that final answer and the appropriate number of significant figures. So I would take the 200 and move my decimal place over 2 spots. So I would have 2.0 times 10 to the second power. So 200 is 2 times 10 squared, or 2 times 100. And I am now technically reporting that in the correct number of sig figs. Again, that was not planned. I just grabbed 2 numbers and put them together via multiplication, and that's what we end up with. So 200 would be the correct rounded answer, but I think to give a more precise answer, you would say 2.0 times 10 squared, whatever units that might be in chemistry. So I hope you found this video helpful. Again, we're just covering scientific notation versus what we typically call in math and science our standard or ordinary notation. And then we went over some significant figures. And hopefully that's a solid review. And again, we have more of that content in our exam review with our 50 questions at the end. So thanks again for watching.